Okay, here we are, Calculus Integrals Part 2, day number 3, improper integrals. As I mentioned earlier, these integrals are improper because we have a limit on one end, but no limit on the other end of the integral itself. So we're going to use the skills we know, which are integration skills, possibly integration by parts, use substitution, or just your standard polynomial integration. And then you'll see a little twist with L'Hopital's rule here on one of these examples. Integral lab, we can work with that later. Let's talk about integrating these, right? What would be the integral of 3 over x dx? Let's ignore the limits on it. 3 over x. That'd be 3 times the natural log, natural log of x, plus c, but since this is a definite integral, we're going to take it from 1 to infinity. I like to use this notation for definite integrals from 1 to infinity. Now, what we do in order to determine what the area under this curve would be as x goes to infinity is we change this variable. Well, it isn't a variable, but I'm going to change it to b. I'm going to go from 1 to some value b. And when I do this, I then take the limit of my expression as b goes to infinity. So now I'm going to plug in my two values. I get 3 times the natural log of b minus 3 times the natural log of 1. Let's pause for a second. What is the natural log of 1? What's the natural log of 1? 0, right? Because e to the 0 equals 1. So this is 0. What would be the natural log of infinity? Oops. What's the natural log of infinity? Infinity. So I really have 3 times infinity minus 0, which is infinity. Therefore, we cannot calculate the area underneath that curve. What? It looks like it converges. It keeps going down and approaching 0, right? This is called the harmonic series, which we'll see later, and it's kind of an anomaly, okay? But if we take the exponent in the denominator, right? This was an exponent of 1. If we take it and we make it a 2, it now converges, and we get an area. I'll show you a proof of that later, okay? Just trust me for now, okay? So let's talk integration of the second one. Let's integrate this. Why don't you take 2 minutes, integrate that with a neighbor, okay? Integrate the second part. Okay, if I integrate, I get negative 2x to the negative 1, because the derivative of that is 2 over x to the second. So far, decent. Okay, now I'm going to place a b in here for infinity, and I'm going to take the limit of these values. So the limit as b goes to infinity of negative 2 b to the negative 1. Instead of writing b to the negative 1, I'm going to write over b to the first. Right? So could I call this, if I wanted to, this? Yeah, I could. Now I'm just going to plug in b, and I'm going to plug in 2, and I'm going to see what I get. Okay, so I get that minus negative 2 over 2. Right? I get this 2 from there. And now as I take the limit, what does this become right here? As b goes to infinity, what does that become? 0. Minus negative 1. So the area under that curve from 2 to infinity is 1. Woo! All right, so this idea of improper integrals of the form some constant to infinity, this is the proof of that. You can go over that on your own time. I want to look at this one because it will have some L'Hopital's rule involved. Okay. So let's first of all integrate that, right? And I see an integration by parts problem. All right, I'm sure you do too. So let's go UV or U dV. From the test, okay, liate, which one of those is higher priority, x or e to the negative x? X. So x will be u. So du will be 1 dx. Okay, and dv then is, was it cosine? No, it's e to the negative x dx. And therefore, v will be negative e to the negative x. Okay, so I'm going to go uv minus the integral of v du. I'm going to ignore these two right here. Am I recording? Good. I'm going to ignore the limits for just a moment, and then I'll bring them back in afterward. Okay, so I get uv minus the integral of v du. So uv is negative x e to the negative x. Okay, minus the integral of v du. I have negative e to the negative x. I'm going to pull that negative out, make that plus. So I'll get e to the negative x dx. Can I integrate e to the negative x dx? Yeah, I already have, actually. Right over here, I integrated it right here. So I see that I get negative x e to the negative x plus a negative e to the negative x. So I'm just going to go minus e to the negative x. Okay, now I'm taking that on these limits, a to infinity. A to infinity. Let's pause for a moment. Okay, so here we go. For those of you at home or on the World Wide Web, all of a sudden this stuff showed up, right? I just rewrote this in this form, and I rewrote this in this form to make things a little bit easier to see as they develop. Okay, so I'm going to take, and I'm going to plug b in here instead of infinity, and then take the limit as b goes to infinity. So let's go ahead and do that. Let's plug b in first. Well, that'd be negative b over e to the b minus 1 over e to the b. Okay, that's my first term. Now I'm going to plug in a, and I get negative a over e to the a minus 1 over e to the a. Yep, we're good. So far, so good. Okay. What will this thing become? Negative infinity over e to the infinity, which is infinity. Okay. That should be a red light. That should flash at you L'Hopital's rule. L'Hopital's rule. We'll get there in a minute. Okay. But this will be 1 over infinity, which will be 0. Over here, I get minus. Oh, gross. How about this? How about I distribute the minus to both of those terms and now have plus a plus 1 over e to the a. Ooh, that's nice. How about that? Okay, so hopefully, I'm hoping that this is convergent here using L'Hopital's rule, which I'm assuming it will be, and then I can add whatever that is to a plus 1 over e to the a. So let's apply L'Hopital's rule to this thing right here. L'Hopital's rule. What is it? Derivative of the top, derivative of the bottom, then plug in infinity. So what's the derivative of the top? Okay, negative 1 over itself, e to the x. So the limit of that as x goes to infinity would be what? 0, right? That'd be negative 1 over infinity, which would be equal to 0. So this also will go to 0. And so I get this answer, right? The integral from a to infinity of x e to the negative x dx will equal a plus 1 over e to the a. And that's all dependent on what I choose a to equal. If it's 5, it'd be 6 over e to the 5th. If it's 12, it'd be 13 over e to the 12th. Right? It's all dependent on what value I pick as my constant. Okay, improper integrals are really not that bad. Okay, it's just a matter of understanding limits and possibly needing to use L'Hopital's rule.